Yo, 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 what's up, pre-calculus? This is Tearing It Up, aka T Money, aka Mr. Taryn, and I'm here rocking with you today. And today we're going to be looking at 2.6, part 1, looking at nonlinear inequalities. Let's get after it. The objective today is to be able to solve these nonlinear inequalities. One of the major things we're going to be talking about, how we want to solve these is by using a sign chart. It is extremely important that you know how to use a sign chart because you're going to be using sign chart a lot when you get into calculus. Here are the steps to solving nonlinear inequalities. The very first thing you want to do is you want to set your polynomial equal to 0. After you do that, you would want to factor, if you can, and solve for the zeros of that function. Notice, if you cannot factor, go ahead and graph the polynomial and see what happens, because there might be times where you have no solution or infinite amount of solutions. And if you're ever not sure with factoring, you can always plug it into your calculator. Then we need to plot our zeros on a number line. Then we need to complete our sign chart by plugging numbers into the different spots. Now this, I will say, this is extremely important. When you plug in numbers for your sign chart, make sure you are plugging into the factored form of your polynomial. If you don't do that, you're going to run into some troubles. I know personally I've made that mistake before, so I wanted to really kind of highlight that. And then lastly, we need to write our statement of our solutions. Obviously, that needs to be in interval notation. So here we go. This is your typical example. Solve this nonlinear inequality. So the first thing I need to do, if you remember your steps, first thing I'm going to do is I'm going to factor this. Notice I can factor out an x, which is a greatest common factor. So I have, let's take a look here. I have x times x squared plus 5x plus 4 is greater than 0. So what I've done here is I've factored out an x. I'm going to continue to factor here, and I get x plus 4. I get x plus 1. Is all greater than or equal to 0. Now that I have it factored, now I want to set each of those equal to 0. So x equals 0, x equals -4, x equals -1. Those are my zeros. So now I'm going to create my sign chart. And I'm going to put these zeros on that sign chart. So I have one at 0, I have one at -4, and I have one at -1. Those are my zeros. So now what I need to do is I need to test a number to the left of -4. So over here somewhere, I need to test a number in between these two. I need to test a number in between these two, and I need to test a number over here. Again, when I'm testing those numbers, I am plugging into this factored form. So let's go ahead and get after this. Let's use green. So the number I'm going to test over here is going to be -5. So if I plug in -5 into the factored form here, I get, if I plug in a -5 right here, that gives me a negative number, -5. And I don't care about the values of the numbers. I just want to know, is it going to give me a negative number or a positive number? That's all we're really looking at for a sign chart. So again, I plug in -5 in here, I get a negative number. If I were to plug in a -5 in here, I would get -5 plus 4 is -1, which is also a negative number. And if I have a -5 in here, -5 plus 1 is also a negative number. And if you think about this, a negative times a negative is a positive, and then a positive times a negative is a negative. So overall, when I plug in this -5, I know that I'm going to have negative solutions to the left of -4. Now we're going to go ahead and plug in a different number. We're going to go ahead and plug in a number between -1 and -4. I'm just going to choose -2. We're going to see what happens. So again, I'm going to plug into the factored form. So that's going to be a -2 is just going to be a negative number. And then -2 plus 4 is going to be a positive number. And then -2 plus 1 is a negative number. Oops, that's okay right there. So I have a negative times a positive, which is a negative, times another negative makes it positive. So those solutions are positive. Now we need to plug in another number this one between -1 and 0. Let's do that right over here. The only number I can think of is -0.5 or -1/2. Let's go ahead and look. So if I plug into the first one, that's obviously going to give me a negative. If I plug into -0.5 plus 4, that's going to be a positive. If I go -0.5 plus 1, that's a positive. So overall, I have a negative times a positive, which is a negative, and a negative times a positive, which is a negative. And then lastly, I got to choose a number over in this section. I'm going to pick 1 because it's an easy number. So 1 is positive, so plugging in for that is just going to give me a positive. 1 plus 4 is 5, and that's positive, and 1 plus 1 is 2, and that's positive. So a positive times a positive times a positive is a positive. So there is my sign chart. Negative, positive, negative, positive. Now I just need to solve, or I need to put those answers in interval notation. Now, if you notice here, my answers, what I want here is I want when it's greater than 0, when that function is greater than 0. It's greater than 0 wherever it's positive. So I'm thinking kind of this interval from here to here, as well as this interval from here to here. So I have to write that. Notice it's greater than, not greater than or equal, so I'm going to use parentheses. So it looks like my graph is positive or greater than 0 from -4 to -1, and then again from 0 to positive infinity. -4 to -1 and 0 to infinity. Those are the intervals where this function is greater than 0, so that would be my solution. Not too bad, right? Let's keep rolling here. So here's an example where I have a question that's not going to factor. I cannot factor that. Because I cannot factor that, I can't do that whole sign chart thing, and it's going to get kind of disgusting. So if you remember from earlier, we can always graph it to see kind of what it looks like. And when I graph it, I get a graph that looks like this. And if you notice, I want to know the solutions where this graph, this function is less than 0. Well, let me ask you, is there anywhere here where the graph is less than 0? Well, no, it's not. It's not below this x-axis. So the answer would just be no solution. Moving on to the next question, kind of the same thing, but this one is asking, okay, where is this function greater than equal to, or greater than or equal to 0? Well, if you notice here, the entire thing has a y value that's greater than 0. So your answer would just be -infinity to positive infinity. So that's some of those questions where you might not be able to factor, but you can go ahead and graph and kind of use your common sense. We got one more question here. Now, this is asking us to solve this. Here's a quick little graph of what this is. And so it's saying x squared plus 12x plus 36 is greater than 0. Let's go ahead and factor it. I believe this factors. That's just going to be x plus 6 and x plus 6. So I have x equals -6 with a multiplicity of 2. Now you don't need to tell me that, but if you think about from earlier, whenever we have an even multiplicity, remember that the graph is just going to touch and not actually go through. So now I got to ask myself, well, where is this function greater than 0? Well, it looks like it's greater than 0 pretty much everywhere, except right here, it's not greater than 0, it's greater than or equal to 0, right? So that cannot be part of our solution. So it looks like our solution set is just going to be -infinity to 0 and then 0 to infinity, because all along those intervals, my y values are greater than 0. I'm not including 0 because 0 is not greater than 0. 0 is greater than or equal to 0. So that was another question. That's pretty much all we got for the first part of 2.6. In the next video, we'll be taking a look at rational inequalities, which are a little bit harder, but either way, hope you enjoyed the video. If you have any questions, reach out to your teachers. We're not mind readers yet. We can't tell. So that's all I got today. Taryn, out.